Alright, today's video is on naming binary compounds in type 3. I promise this is the last type. There's no type 4 or type 5. After this, we are finito with binary compounds. Now, we're not completely done with naming, and we'll spend time, and you'll have a lot of time in class as you work through your goal sheet to kind of get the hang of this. But again, chemistry is another language, and these are the vocabulary. These are the vocabulary words. So. Okay, I know you've been waiting for it, so today's polyatomic ion of the day is, ta-da, it's right there, and SO4 2- is known as the sulfate ion. So keep that one in the memory banks. We'll talk about this at the very end of the video, and the video joke of the day, what do you call 10 cards? And I want you to think back to the units of measurement, right? Kilo means 1,000. Milli means 1,000th. Do you remember what 10 was? What was the prefix for 10? Well, 10 cards you could call a deck of cards. Get it? A deck of cards? Anyways. Alright, so naming binary compounds. Type 3 binary compounds consist only of 2 nonmetals. So when we're looking at the periodic table, oh, and look, there it is. Look, there it is. Look, there it is. Here's the periodic table. Now, type 1 binary compounds, the cation came from family 1, the alkali metals family 2, or this family. And then we did, in the last video, type 2 binary compounds have a transition metal as their cation. Now, type 3 binary compounds don't have any metals in them at all. So, it'll just be very small number of elements, just these nonmetals here, that can make up the type 3 compounds. So that's good. We have a very small target. Okay, so let's take a look at the rules, and we'll practice a few, and you'll have the hang of it in no time. Okay, so as promised, here are the rules, and very simple. We'll go through an example. So I'm going to put one on here. So S2O. And again, if you don't believe me, you can check, but both S, sulfur, and oxygen are in that part of the periodic table where the nonmetals live, where they hang out, you know. And when you have a binary compound, and you'll get better at this as the year goes on because you'll have more practice, but right now you probably didn't know that this was a nonmetal. So when you're doing these in class, the first thing you check is that first element. Is it a metal or not? If it's a metal, then you name it using the rules we did for type 1 and type 2. However, if it's a nonmetal, rules are just slightly different. And again, you can read the rules here with me. I'm just kind of do it in the problem. The first rule, basically you name the whole element, the first element. So this is going to be, we're going to use the whole name of sulfur in the name. So sulfur. And the second atom gets the IDE ending, just like we had before. So this will be ox. Now, here's where it's a little bit different. There are many types of sulfur-oxygen compounds. For example, SO could exist. There's an SO3, there's S2O3, and so on. So because there's these versions, these different versions, we need a way to differentiate which version of the sulfur-oxygen, for this example, compound we're talking about. Because as a chemist, you don't want to go to the hospital and say, Doc, I need sulfur oxide. And he's like, well, which one do you need? He gives you the wrong one. So you can see why it's important as a chemist to know how to name these. So what they have is they have a prefix list. For now, you don't have to memorize it. But I would, by the end of the year, expect that you know these 8. They're pretty self-explanatory. Mono, you know the monorail at Disney World and the Epcot Center has 1 rail. Di is 2, tricycle 3, tetra, Tetris. There were 4 different shapes in Tetris. Penta, the pentagon, right? Octopus has 8 arms. So pretty maybe intuitive words that you're familiar with. So we look, the first element, if it has 1, you don't put a prefix. If it has more than 1, you put a prefix. So we're going to put a prefix in front of this. So this is going to be di. So it'll be disulfur. And the second element always gets a prefix. So we have to put a prefix in there. So this is going to be, and I'll have to write it in like this, mono. Now, so the final name for this, let's go, I'll just go up here and write it. So this is going to be disulfur monoxide. And you may notice that when I wrote the name for this, there were 2 O's down here because it's mono. It's mono, there's an O there, and then there's an O there. But up here, I just left 1 O. If you have back-to-back O's, you can drop one of them, because then it would be like disulfur monoxide. And if you had a bunch of chemists going, disulfur monoxide, disulfur monoxide. I don't know, it sounds kind of British, maybe? I don't know how that sounds. So let's go and take a look at a couple. Alright, so here's a good one. PCl5. I'm telling you this is type 3 for right now. In fact, both of our examples will be type 3. So let's do N2O5. So I'll go through and name. The first element, if there's only 1, doesn't get a prefix. So there's only 1. So no prefix needed, and it gets its full name. So this is going to be phosphorus. By the way, when you were a kid and you threw those little cap things on the ground, they pop at people's feet. They contain phosphorus. The match, the red chemical on a match is phosphorus. So it's a very common and can be very flammable chemical. So phosphorus. Second element, chlorine. The second element always gets a prefix. There's 5, so we look at the prefix list, and that is penta. And then we give the ide ending, so pentachloride. So phosphorus, pentachloride. And now let's take a look here. N2O5. First element, no prefix if there's 1, but there's 2, so we do give it a prefix. So this is going to be dinitrogen. And oxygen has 5, so this is going to be, again, penta. And if you have back-to-back vowels, I shouldn't have just said O's, I should say back-to-back vowels. At the chemistry part, this would be a little bit embarrassing here, where you put the prefix and the element. Get rid of the back-to-back vowels, and you always side with the O. So this, we could get rid of this O, and it would just be pentoxide. So dinitrogen pentoxide. And kind of to finish up here, this is interesting, and I think this came up at the beginning of the year. We've talked about this. Water, technically, you know this is water. I know this is water. Everybody knows this is water. Has the actual name. This is a type 3 compound, so we should name water this way: dihydrogen, and there's 1 oxygen, so it should be monoxide. Right? Now, that sounds much, much scarier than water. And there's a whole website. If you want to Google it, that could be one way to earn some gold points and come in and kind of maybe we'll have a discussion about it. You could make water sound like the most dangerous thing in the world, and they do on these websites because they refer to it, first of all, as dihydrogen monoxide. And the properties are such that, like, the solid version of it could cause death. Being immersed in the liquid version of dihydrogen monoxide can cause death. Accidentally breathing in dihydrogen monoxide can cause death. And these are all things that sound really scary, but if I replace the word water, being immersed in water can cause death. Well, yeah, it's called drowning. Breathing in water can cause death. Well, yeah. So, as you become chemists this year, and you wonder, well, why do I have to take chemistry? Well, one of the beautiful things about it is as you become more literate in the language, words like this become less scary, and you're not as easily duped. A lot of the advertisements take advantage of that fact that most Americans aren't scientifically literate.